Hello students, now we are going to study probability distributions, random variable and probability distribution. This is basically a combination of a probability theory and your binomial expansion. With the basic levels of probability and basic levels of binomial expansion, when we combine, we get this more subject understanding. Okay, let us see. See, suppose two coins are tossed. What are the possible outcome? Head come, head tail head, and tail. So what is the probability that two heads will appear? Is only one choice. So 1/4 is the probability for the two heads to appear. What is the probability for zero head to appear? For zero head to appear, again this is only one option, TT. So again zero head also 1/4. For two heads also 1/4. For one head, see there are two options. So 2/4. So it has distributed. If I take my variable, my random variable as getting head, number of heads. My random variable as getting number of heads when I do two coins toss. So for two heads, my probability is 1/4. For one head, my probability is 2/4. For zero head, my probability is 1/4. So for when x is 0, that means I'm getting 0 heads. My probability of x is 1/4. When x is 1, that means I'm getting 1 heads out of this trial. My probability is 2/4. When I want 2 heads, probability is 1/4. If I add this sum, if I add this is 1. Because I have taken all the possibilities of heads coming in the situation. So my total probability is 1. So this is suppose coming head or no head. That is a condition. Which is having head or no head. That means it is a full probability. So that is 1. So if you take this as frequencies, suppose if I am taking this as frequency 1, frequency 2, frequency 3, and this is xi. So what is the sum of the frequencies? Sum of the frequencies is 1. Earlier in our probability theory, in our mean mode median, sum of the frequencies is n. So we call it as n, sigma xi by n. Sigma fi xi by n is the mean. Sigma fi xi by n is the mean. So, but here n is what? Here n is 1. So here mean becomes sigma fi xi. That means sigma x into pi. Sigma x into pi. So this is the mean. Because by fi, sigma fi is n. N we consider n as 1. So you understand basic probability distribution among the n with respect to random variable. So in this case, the random variable, your heading is random variable. Random variable is coming number of heads possible in this experiment. Let us see the same experiment with 3 coins. I have tossed 3 coins. So these are the 8 possible steps. 3 coins. So for next, I will see x is 0. Number of heads is 0. What is the possible? Only 1. So 1/8. The probability is 1/8. X is 0 is 1/8. Suppose I want a number of heads 1. What are the possibilities? That one head only will appear. So how many are there? One head, 1, 2, 3. So 3/8 is 1 head. Three cases are possible. So my x is 1 is 3/8. X is 2 is also 3/8. I want all the 3 heads. All the 3 heads only one possibility. So 1/8. So same table appears here. X is 0. My possibility is 1/8. X is 3. My probability is 1/8. X is 1 or 2. My probability is 3/8. 3/8. Understood? So this is a random variable is getting number of heads, and probability is of that heads. Here, you see here, how this 1 by 8 has come. 1 by 8. Suppose I want 0 heads. 0 heads means T should appear. So first T, what is the probability of getting T in first trial? 1 by 2. What is the probability of getting T in second trial? Again 1 by 2. What is the probability of getting T in third trial? 1 by 2. So all three together, A intersection B intersection C, I have to get. So 1 by 2 into 1 by 2 into 1 by 2. That is 1 by 2 cubed. That is 1 by 8. 1 by 8. Here also same. If you see here, 1 by 2 into 1 by 2 into 1 by 2, 1 by 8. But these two heads can come in 3C2 ways. There are two heads can be first coin, second coin, first coin, third coin, like that. So 3C2, if I do into 3C2, that is 3. 3 into 1 by 8 is 3 by 8. So basic fundamentals of probability, and we have to combine here with the distribution of the probability, and sum of the probabilities of all the cases is 1. Let us see same thing case of a dice. There are 1 to 6. So what is the probability of getting odd number? 1 by 2. What is the probability of getting even number? 1 by 2. So 1 by 2 each. So this is random. Here random variable is odd number, X is odd, X is even. So we have just combined how a probability is distributed over a possible outcomes. So their variable can be a discrete variable. Discrete means what? Discrete means like that 0, 1, 2, like that. Number of heads. It cannot be 1.1, 1.001, 1.00001. No, it's not a continuous curve like sine theta. Sine theta is a continuous curve. Cos theta is a continuous curve. So it is not like that. It is a discrete numbers. 0, 1, 2, basically in integers. Basically integers. So this is one type of random variable. Can be a discrete one or can be a sine theta, cos theta of a continuous type of nature. But our scope is limited to discrete random variable. Now you see here, same one more example. 2 balls from a bag are drawn, which contains 3 red balls and 2 black balls. Blue balls, let us say, blue balls. So 3 red and blue. So the first line is getting both red. Random variable is I want 2 red when I draw 2 balls. So first red is a possibility 3 by 5. And second red possibility is already 1 red is drawn, 2 are left out, 2 by 4. So 3 by 5 into 2 by 4, 3 by 10 is my 2 reds outcome. Similarly, red and blue, 3 by 5 into how many blue are there? 2. How many left out coins are? 4 balls. So 2 by 4, 3 by 5 into 2 by 4, 3 by 10. This is also 3 by 10. See the last one, blue, blue. First possibility is 2 by 5 because 2 blue out of 5 balls. Second possibility is 1 by 4. So 2 by 5 into 1 by 4, 1 by 10. So here probability of BB is 0. Here no red has come. Random variable says no red, 0. Here 1 red. Here 2 reds. So this is random variable 0, 1, 2. So 0 is 1 by 10, 2 is 3 by 10. This is 6 by 10. We have to add these two. Both possibilities are first red blue can come, first blue red can come. So we have to add 6 by 10. So this is we have just refreshed our probability methods. For coins, it is 1 by 2, 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 1 by 2 for coins. Okay, good. So let us understand this variation. We have seen this 1 by 4, 1 by 2, 1 by 2 for 2 coins, 1 by 8, 3 by 8, 3 by 8, 1 by 8 for a 3 coin. For a dice, it will be 1 by 6. Yeah, appearing 1 on the top, 2 on the top, 3 on the top, 4 on the top. So this is the random variable. This is the probability distribution, and sum of the probability distribution is 1. So you add all this 1, 3, 6 plus 2, 8 by 8, that is 1. So now condition of probability distribution is xi should be greater than or equal to 0. This probability should be greater than or equal to 0. It cannot be negative. First condition is it cannot have minus 1 by 8. It can have 0. 0 is possible, but it cannot have minus. First condition. Second condition is total of all the xi's have been appearing. So total of probability is 1. Sigma of all probability is 1. It is like a frequency distribution. Probabilities are like frequency. So here, what is my mean definition? Sigma xi fi by sigma fi. Sigma xi fi. Xi means xi. Fi means pi here. By sigma fi is 1. So the mean is sigma pi xi. Again, what is the variance? Pi xi square, sigma xi square, pi. Sigma p xi. Xi minus mu. Mu is mean. So I want this difference. X minus x bar. X minus x bar, it can come plus, it can come minus. To avoid plus minus cutting out, I am using square here. So if it is minus, minus square. Plus, plus square. So frequency into mod of xi minus mu whole square, sigma, divided by sigma pi. Sigma pi is again 1. So this can be written in another form. Sigma square is sigma pi xi square minus mu square. Because we have done this earlier, you will get xi square plus 2 mu I xi minus plus mu I square plus 2 mu I xi is equal to 2 mu square. So x square minus mu square. So minus 2 xi mu I, xi mu. 2 sigma xi is mu again. So minus 2 mu square plus mu square becomes minus mu square. This we have done in probability distribution. So that is why n is not appearing here, because sigma n is 1. This is the mean and variation for the probability distribution. Let us see some examples on mean and variation. Find the mean and variation for the dice problem. Dice is 1 by 6 all for 1, 2, 3, 1 to 6. So sigma pi xi. 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6. So this is 7 by 2. This is not 3. Just see, it is 3 by 5. What is this? 3 by 5. What is the average of this? Definitely these 3 digits. Average is 3.5. Same. It is simple mean. Average is 3.5, which is coming in this also. What is the variance here? Sigma square pi xi square minus mean square. Pi 1 by 6 into 1 by 2. 1 square plus 1 by 6 into 2 square plus 1 by 6 into 6 square minus 7 by 2. So this is the mean. So I am getting 35 by 12. 35 by 12. What is this? 35 by 12 3s are 36. 12 3s are 36. Slightly less than 3. So the variance is around here. This point is the variance, standard deviation. Not 3 point. So let us see, for this data, we have to find out mean and variance. We know sum of p is 1. So when I add this and equate to 1, I am getting k value. So I submitted with the k values. Submitted the k values here. Now I know k, x and k. This is x, this is p. So sigma pi xi. So minus 2 into 0.1 plus minus 1 into 0.1. I am adding. Finally 3 into k is 0.1. 3 into 0.1. So I am getting 0.8. 0.8. So the mean of this data is 0.8. See, x can be negative. Only p cannot be negative. X can be negative, but p cannot be negative. So data is 0.8. So average, if I take average with this frequency, I am getting minus point, plus 0.8 in this line. Okay, now we'll go to what is variance? Pi into xi square minus 0.8 square. Mean is 0.8. 0.8 square Pi into xi square. So 2 square into 0.1, 1 square into 0.1, 1 square into 2k, 2 square into 0.3, 3 square into 0.2. So I am getting 2.16 as my variance. This is variance. What is standard deviation? Standard deviation is sigma. So I have to put under root of this. So but we are limiting to variance. Variance is sigma square. You understood? So if for a given data, in a probability distribution data, we can find out mean, variance, so that the only limitation here is sigma p is 1. If sigma p is not 1, then here I have to get by sigma pi, sigma f, I will get some other figure. So in this particular probability distribution, we are getting sigma pi is 1. Okay. Again, some more problems on mean, and we'll bring this also top. We have a data here. This is probability distribution. This is a x variable. This is a discrete variable. There is no points. There is no continuation. It's a discrete variable. So what is the find mean and variance? So you know sigma p is 1. So I am adding 9k plus 10k square is equal to 1. So 2k square plus k square plus 7k square. 10k square. I am adding all k's. That is 9k. So when I solve this, I am getting k as 1 by 10 or k as minus 1. Is minus possible in the probability? No, it's not possible. So k we have to take as 1 by 10. Even minus 1 also, sum of p will be 0. But this is not applicable for probability. I should get at least 0 and above. Okay, now I get 1 by 10. It need not be integer. This has to be integer, this need not be integer. This has to be positive, this need not be positive. Please remember these 2 points. Now let us go further. So I am submitting here. All k's are submitted. So now I am putting me. 1 into k plus 4k plus 6k plus 12k plus 5k square plus 12k square plus 49k square plus 7k. So when I'm adding, putting k, I'm getting 3.66 as my mean here. So here 3.66 is the mean with this frequency distribution. So what is the variance? Is not asking variance. What is asking is p 0 less than x less than 5. See the difference, 0 less than or equal. If it is equal given, 0 also we have to include. If equal not given, I have not 0, I should not include. Here also is it equal given? No. So 5 I should not include. What are left over? 1, 2, 3, 4. So P1 is k, P2 is 2k, P3 is 2k, P4 is 3k. So I have to add all this. P1 to 4, I am adding all this. 4. So answer is 4 by 5. So it can ask like this. P, the random variable is between 0 and 5. That means I can get 1, I can get 2, I can get 3. I should not get 0, I should not get 5. If it is equal given, I have to include 5 also. If it is equal given here, I have to include 0 also. Because 0 is 0, no problem. So let us see. It is said that range of x is 1 to some infinity. 1, 2, 3, like that goes up to infinity. P of x is defined as, this is P of x, defined as c to the power of k by k factorial. Find what is c and what is p of 2. So let us put the sigma. We know that sigma p is 1. Sigma p is 1. So sigma c to the power of k by k factorial is equal to 1. That means was c by 1 plus c square by 2 factorial plus c cubed by 3 factorial, that is equal to 1. So I am adding both sides 1. 1 plus c by 5 factorial, c square by 2 factorial, that is equal to 2. You know this series represent my e to the power of x. How e to the power of x squares is defined? 1 plus x by 1 factorial plus x square by 2 factorial plus x square by 3 factorial up to infinity. This is e to the power of x. So in place of x, we are having c here. So this is nothing but e to the power of c is equal to 2. That means log 2. C is equal to log 2. I take both sides logarithm. Log 2 is equal to log e to the power of c. C log e to base c is equal to 1. So c is log 2. Once I get log 2, what I want? P x is equal to 2. So I put c to the power of square by 2 factorial. C square by 2 factorial. So 1 by 2 into log 2 whole square. Log 2 whole square is not 2 log 2. Log 2 whole square is not 2 log 2. So this is, let us see another way. It is given x 3 variables, 3 random variables, and these are the properties distributed in C. So we know sigma p is 1. So I am adding all these 3 is equal to 1. So when I solve this, what I am getting? Sigma c is 1. This is c cubed. What is this? This is 3c cubed plus minus 10c square plus 9c minus 2. So I am just putting 1 here. 3 plus 9, 12 minus 12, 0. So c minus 1 is a factor to this. So I am dividing with this equation with c is equal to 1. So this is my division aspect we learned earlier. Or I can use 3c cubed minus 10c square plus 9c minus 2 divided by c minus 1. I'll put here 3c square. So 3 is like that also it can be divided. This is one way of division. 0 I put 3, 3 ones are 3. Again add minus 7, 7 ones are 7. Add 2, 2 ones are 2. Add 0. So this is my leftover. What is my leftover? 3c square minus 7c plus 2. So this is 3 2s are 6. So minus 6 minus 1. So this becomes 3c minus 2 into 3c minus 1. C is equal to 2 or 1 by 3. C is equal to 2 or 1 by 3. Suppose if I put C is equal to 2. Let us say here. What will become here? 4 C's are 8 minus 10 into 4, 40. This is becoming minus. Minus is not allowed. So C2 is not acceptable. So C is 1 by 3. So we have to check up. Sum is 1 and each probability should not be negative. So these are the two conditions with which this probability is defined. So 2 is not applicable here. So here this is plus, this is also plus, but this is becoming minus. See the range from observing P should be greater than 0. So that means 4C should be greater than 10C square and 5C should be greater than 1. 5C should be greater than 1. That means what? P into 1 by 2. With these constraints, C is 1 by 3. Now what is asked? P 0 to 3. 0 less than, equal is not there. So I want 1, 2, 3. 1, 2. There is no 3 here. So I add 1 and 2. So P1 and 2 is equal to. So equal is not required because 3 is not there. Okay. So I'm adding P1 plus 2. P1 is what? 4C minus 10C square. 2 is 5C minus 1. This is 5C minus 1. This is 4C minus 10C square. So I'm getting 8 by 9 as the answer. So this way, the mean and probabilities can be given. Now we'll go to binomial distribution. This also binomial distribution. So now we have just understood how a random variable is given, how the mean and variance are calculated from a random variable. Let us continue random variables and probability distribution. So far we have done for general category, mean and variance. Now we are going to see binomial and Poisson's expansive patterns. Okay, let us see. See, now we are discussing on the binomial distribution. Binomial distribution of probability of various random variables. Let us say there are n trials. There are n trials. I want in n trials x n times I have done tossing. That is n times I have done coin tossing. I want x times head should come. X is a general factor. Like it can come 1 time, 2 time, 3 time. Suppose 1 time it has to come. So out of n trials, 1 trial it has to come. What is the probability? Out of n trials, x trials, I need heads. What is the probability? Let us say if the success probability is P and failure probability is Q. So P plus Q is equal to 1. Here in a coin case, it is 1 by 2, 1 by 2. Head can come 1 by 2, tail can come 1 by 2. But in general cases, it need not be 1 by 2. It can be 1 by 3. Suppose question answers are there. 4 questions are given. You have to put tick 1 correct answer. So what is the success rate? 1 by 4. What is the failure rate? 3 by 4. Because 3 questions can be wrong. 1 question only will be right. 3 will be wrong. So failure probability is 3 by 4. Success probability is 1 by 4. But in coins case, it is 1 by 2, 1 by 2. But in general case, let us say it is a P and it is Q. So automatically P plus Q should be 1 because 1 by 4 plus 3 by 4 is equal to 1. So in that case, so here P plus Q, this is success rate, this is failure. Half plus half, 1 by 4 plus 3 by 4, 1 by 8 plus 7 by 8, like that. So the both probabilities of success and probability of failure. Coming heads or no heads. Coming tails or no tails. So both are covered. So both together will become 1. So now I want x tails. So x, what is the probability of each time? P. I want x times. So p to the power of x is the probability of getting my success. Heads, p to the power of x. And other q, p to the power of x. Now what is, now n minus x items I should get q. I should get tail. I should not get head there. I should get tail because I want head only in x numbers. So p in each time, so x times is a p to the power of x is the probability. But other n minus x times, I don't want head, I want tail. So what's the probability of n minus x tail? Q. So q to the power of n minus x. So what is the total probability of getting x, only x, is p to the power of x into q to the power of n minus x. Understood? P to the power of x into q to the power of n minus x. How this has come? P is the probability of success. I want x times. So each time my probability is P. P may be say 0.2. For a coin case, 0.2 into 0.2 into 0.2 x times. And you should not, other n minus x times, I should get a tail. So tail also 0.2, 0.2 into 0.2 into n minus. So it is 0.2 to the power of n. 0.5 to the power of n, 1 by 2. 0.2, no, it's not 0.2, it is 1 by 2. Okay, 0.5. So now, if it is P, if it is Q, then the probability of getting x in n trials is p to the power of x into q to the power of n minus. Now this x out of the n trials can be selected. This x can be 1 to x first and next onwards will be tail, or x can be 2, 1 alternatively or tail. So there is possibility selecting x from P, we know PCX, NCX. Selecting x plus n, we know NCX phase. So x can be selected in NCX phase. So the total probability is NCX phase into p to the power of x into q to the power of n minus x. This is my total probability of getting heads or getting a success, getting correct marks. All these things is NCX into p to the power of x into q to the power of n. Suppose x is 1. So this is n into p into q to the power of n minus 1. Like that. So for any x, if I want 1 success, I want 2 success, I want 10 success, x is a variable less than n. So I all to be successful. NCN. N is 1. So p to the power of x, q to the power of all, p to the power of n into q to the power of 0. So p to the power of n is my all success. So this is the probability. This is varying. For n0, for n1, for x1, x is 0, x is 1, x is up to xn. This varies. So suppose for x is 0, what is becoming? nc0, q to the power of n, p to the power of 0. For x is 10, nc10, p to the power of 10, q to the power of n minus 10. So if you see this distribution, it is like q plus p whole to the power of n. We know binomial expansion, q plus c whole to the power of n, q to the power of n, nc0, q to the power of n. This is point. nc1, q to the power of n minus 1, p to the power of 1, nc10, q to the power of n minus 10, p to the power of 10. So this, the probability distributing among trials which has two options. Either it can success or failure. 1 or 0. 0 or 1. So these are only two options. You do not have many options. It has only two options. So in such case, the distribution of probability is a binomial expansion. And the coefficients of binomial coefficients are their probabilities for respective random variable. Random variable is success attempts. That means it can be heads, or it can be correct answers, or it can be correct assumptions, whatever it is. Success assumptions. So you understood how this q plus p whole to the power of n has come? Because p to the power of x is for x items with the probability p, x times. So q to the power of n minus x is for the other probability. So a integral p is equal to p by x into q to the power of n minus x. It ncx times it can be selected from the n. So this is nothing but a binomial coefficient of expansion. So this is represented as random variable x, number of successes, is binomial of n and p. N is what? Number of trials. P is what? Success probability. If it is coin, it is half. If it is some other, if it is question answers, it is 1 by 4. Like that. So once p is given q, you know, 1 minus p automatically is no. So these are the conditions for the binomial distribution. Fixed number of trials. N cannot be go down to infinity. Maximum n can be 100 or 50 like that. If it goes beyond 100, it is very difficult. Then we come under Poisson distribution. But less than 50, 100 becomes our binomial distribution. N should be a number of fixed number of trials. Each trial is independent. Means one trial should not depend on other trial. Here you see here. This is a dependent trial. If I taken out red, but how many reds are available? 2 only available. How many total quantity? 4 available. So the probability is getting reduced here, 2 by 4. Otherwise, if it is replaceable, suppose if it said x is one red is taken, again I replace it. So again, my 3 by 5 probability will come. So the experiment is, here it is independent. Once I replace, if I don't replace, this is not independent. So in my probability theory, they are all independent. One coin tossing does not depend on earlier coin tossing. Each trial must have all outcomes classified into 2 categories: success, fail. There are only 2 because I have 2 here. P, Q. If a third one also is there, then I have to put R to the power of also something. But trinomial is only between 2, binomial. It is not trinomial, it is binomial. 2 factors. The probabilities must remain constant for each trial. So the P is constant. P cannot vary in this trial. I get P to the power of x. If P is varying, first time P1, second time P2, third time P3, then I have to multiply P, P1, P2, P3 like that. But P is assumed as constant. So P constant means Q also constant. 1 minus p is q, also constant. So this is my binomial distribution. So for a probability of an x getting number of heads 10 times, 5 times, 6 times x is equal to ncx, p to the power of x, q to the power of n minus x. ncx is what? N into n minus 1 into n minus 2 up to n minus x plus 1 by x factorial into p to the power of x into q to the power of n minus x. You see, this is my binomial distribution. Suppose n is 5. Suppose n is 5. So to get one trial, 5c1, 5c0, 1, 5c1, 5c2, 5 into 4 by 2, 2 2s, 5 2s are 10, 5c3, 5c4, 5c5. So this is a distribution. This is a 5c1, 5c0, 5c5, 5c1, 5c4, 2, 3. Similarly, 4 trials, 4c0, 4c1, 4c4. This is 4c1, 4c3, 4c2. So this is binomial. This is a binomial distribution. P is given, Q is 1 by ns p. So what is the mean of a binomial? Earlier we have found out mean and variance here. On mean and variance. So this is also variation, the probability variation. This is a random variable. Here also we have a random variable x, x0, x1, 2, x10, and we have a probability variation in the binomial form. So what is the mean of this? Mean is represented as mu is equal to n into probability. N into success probability. What is variance? N into P into Q. N into P into Q. Let us see these two, how we have got derivation. Mean definition is what? X into P by sigma P. X into P by sigma P. Sigma P is 1. So X into P. So P is constant. I am taking out P out. Sigma, sigma n. Let us see this. Let's go down. Derivation of mean and variance of a binomial. X is what? U1 to Un. Probability x, E means expectation of x. Probability of x is P1 to Pn. So total probability P1 to Pn. Ex is equal to EU1 plus EUN. These are all different probabilities. I am adding all probabilities. This probability is P. One time probability is P. Second also I have done. Second also probability P. Third also probability P. I am adding 10 times this P. So the mean is n into P. So expectations of each activity. Each activity, the probability of getting is P. Again, probability of getting head is P. Again, probability of getting head is P. Like that, all P's are added, it becomes NP. Same is the case with variance. Each variance of one is P into 1 minus P, which is Q. Again, this is our second one also P into Q. This is also P into Q. So total is P n into P into Q. But this we are not able to understand, then we'll go for mathematical reference. This is a simple addition reference, mean and for a probability distribution of binomial. But let us go for a mathematical deduction. This we are not able to visualize. We know x into px is the mean divided by sigma p. Sigma p is 1, so that is removed. X into px as x is 1 to n, 0 to n. So this, what is the probability of px? ncx, p to the power of x into q to the power of n minus x. So here what I am taking, x first will be 0. So I am expanding ncx, n by n minus x factorial, x factorial, p to the power of x into 1 minus p to the power of x. Here I am xx getting cancelled. Here become x minus 1 factorial. So I am taking out one n out, becomes n minus 1 factorial. So I'm taking out one n from here. I'm taking out one p from here. So p to the power of x minus 1. So np if I'm taking out, what I'm getting n minus 1 factorial by x minus 1 factorial into n minus 1 minus x minus 1 is n minus x. N minus 1 minus x minus 1 is equal to n minus x into p to the power of x minus 1 into 1 minus q to the power of n minus 1 minus x minus 1 is n minus x. So I can write n minus 1 minus x minus 1. So when I put x minus 1 is equal to y, then y starts with x is 1 to this, then y starts with 0 to n. 0 to n minus 1. We start with y is 0 to m, and I put n minus 1 as m. N minus 1 as m. Then this becomes m factorial by x minus 1 as y. So mcy. N minus x is m minus y. So this becomes mcy. mcy into p to the power of y into q to the power of n minus y, m minus y, m 0 to m. So this is a full probability. 0 to m, you see, further definition. If x is not there, 0 to n, x is not there, this whole is 1. Because sigma of all probabilities is 1. Since x is there, I have taken out x outside, x factorial x minus 1. So n also n minus 1, p also p minus 1. So then I converted this into a whole probability. This has converted to y is 0 to m, mcy, p to the power of y, 1 minus p to the power of m minus y. There are m trials. Basically, m trials means 0 to m. So this probability for m trials, I am adding all probabilities. This is 1. So answer is n. Answer is n. This is the mean. You understood? What I have done here? I have removed x and x is already cut. So n and p taken. Rest I have proved this as 1 because sigma of all probabilities. 0 to m trials. In an m trial, I have this probability distribution. So this is also 0. 1. So np into 1. Let us see variance. How variance is defined as e into x minus x bar whole square. Okay. Probability into x minus x bar whole square. And when we simplify it, I get p into x square minus x bar whole square. This is x bar whole square. These are we have done in standard deviation. Earlier I said x square plus mu square minus 2x mu. Minus 2 mu into x is equal to sigma x is equal to mu. Minus 2 mu square. So plus mu square minus 2 mu square minus mu square. So minus. This we know. This is mean. Mean we have just calculated NP. E of x is mean. This is mean. This x into p whole square. X into p is mean. This is x into p. Sigma x into p. Px. Sigma x into px. So this we know NP. Let us calculate E x square. We are only concentrating on E x square. That means what? X square into NCx p to the power of x minus p whole to the power of n minus. This is q. Q to the power of n minus x. Now I have x square, I have x here. So I am writing this as x square as, first I am calculating x into x minus 1 because I have to cut the factorials. So I need x into x minus 1 here. So what is this? E x square minus E x. What I am calculating? E x square minus, this is what? Multiplication. X is nothing but what? Multiplying. This is multiplying. See, the way x into px, this is x minus x bar whole square into px. This is multiplying the probability. X minus x bar whole square into px. E is px. Sigma. E is nothing but sigma px. So E x square is equal to x square into this. So E into x square minus x I am calculating. So out of which E x I know from here. So I'll find out E x square. So when I put this, I'm multiplying x into x minus 1 into n fact ncx p to the power of x q to the power of n minus x. Here these two get cancelled. This will become x minus 2 factorial. So here I have taken n into n minus 1 out. N into n minus 1 out. Here I have taken p square out. So n minus 2 factorial, x minus 2 factorial, n minus 2 minus x minus 2, s minus x factorial, p to the power of r, q to the power of n minus r. So this is my standard practice from when m is 0 to m. So this become whole amount, this sigma becomes sigma of all probabilities, that is 1. So E into x minus 1 is equal to n into n minus 1 p square. So I put E x square is equal to, this minus x will come here, minus x will come here. So E x square minus E x bar whole square. This is basically, this is the equation, variance. This is the variance. So my Ex square is equal to n into n minus 1 p square plus np. Because this minus Ex will come here, it will become plus np minus np whole square. This is np whole square. X into E is np. We have just seen x into E is np. This is mean. Mean square is np whole square. This is x into x minus 1. So x into x minus x. Ex is taken this side. So plus np. So n into n minus 1 p square plus np minus np square. This np square came from here. This np came from my ex coming to this side. This one is n into n minus 1 p square of both. So this x is added here. So when I simplify it, what I am getting? Np into q. N minus p is q, np q. So this is my variance. This is my mean. Alright, binomial distribution. This is something. Pi into x square minus mean square. X into pi. Xi into pi. Pi into xi square minus mu square. So let us see some solved problems of the exercise. If n trials of tossing a coin took place, coin is half. So find out x4, 5, 6 are number of successful heads are in AP. Out of these n trials, they are in AP. Find n. Find n. Now we know what is the probability for getting 4 heads out of n trials. NC4, p to the power of 4, q to the power of n minus 4. Here both are 2, 1 by 2, 1 by 2. So 1 by 2 to the power of n will come. 1 by 2 to the power of 4 into 1 by 2 to the power of n minus 4. So 4, 4 get 0, 1 by 2 to the power of n. So NC 4 by 2 to the power of n. This is NC 5 by 2 to the power of n. This is NC 6 by 2 to the power of n. How you got 2 to the power of n? 1 by 2 to the power of 4 into 1 by 2 to the power of n minus 4. So n minus 4 plus 4 is n. So 1 by 2 to the power of n. So these are in AP. These 3 are in AP. That means what? NC say 4 by 2 to the power of n plus NC 6 by 2 to the power of n is equal to 2 into NC 5 by 2 to the power of n. 2 to the power of n can cancel. When I am doing the calculations, I am getting n minus 7 into n minus 14 is 0. So n can be 7, n can be 14, which is satisfying this condition. For n 7 trials, I will get they are in AP. For n 14 trials also, I will get they are in AP. So understood how we proceed? This is a binomial probability distribution. Now let us see another question. Number of trials required getting at least one head. At least one head at 0.8 as probability. I want what? Suppose 5 trials I have done. I want at least one head. I want this one head with 0.8 surety. 0.8 surety. If it is one surety, I have to do infinite times. He is asking 0.8 times. Let us see. So I am considering it as 0 trials. I am getting 0 heads. So 1 minus 0. It is like probability. No heads are coming out of trials. So 1 minus NC0 by 2 to the power of n. Here we have seen for 0, NC0, 1 by 2 to the power of 0 into 1 by 2 to the power of n minus 0. So 2 to the power of n. This probability I want 0.8. So when I simplify to calculation by trial and error, I am getting n is 3. 2 to the power of n is more than 5. So n1 it is 2, n2 4, n3 8. So it's just meeting the required. So there are 3 trials are required with a confidence level of 0.8 to get at least 1 head. Otherwise also if you see 3 trials, these are the 8 are the possibilities, TTT 7 up to HHH. There are 7 ways where we can get head. 7 by 8. What is 7 by 8 probability? 0.875, which is more than 0.8. If it is 2 trials, there are 4. 3 by 4 is the probability, 0.75, which is less than 0.8. So I need 3 trials. This is if it is complicated. If P and Q are complicated, we have to use this process. But these trials we can use. Suppose we said 0.4. I need not. I cannot go on trial and error for 0.4. I have to simply this I have to equate it to 0.4. Okay. Now, probability of a bomb hitting a bridge is 1 by 2. Half is the probability. If I hit, half is the probability. 2 out of 2, 1 will hit the bomb. And 3 hits are required to destroy it. So, the least number of bombs required so that the bridge is 0.9 probability I am going to hit. Suppose if with this half probability, if I put 6 times, I will get 3 hits. I will get 300 hits. Whether it is 6 or it is 5 or what trials to get 0.9, let us see. So, Px is 0. At least 1 hit and 3 direct hits are needed to destroy it. 3 direct hits are needed to destroy it. So, 0.9. So, out of n trials, I should have a probability more than 3. Hitting more than 3. So, I am taking probabilities which are hitting less than 3. So, 0 hitting, 1 hitting, and 2 hitting. These 3 together should be less than 0.1. Then only my 3 direct hits above minimum 3 hits. 3, it can hit 3, it can hit 4, it can hit 5, it can go up to n trials. So I have to add all those probabilities. Instead of all those probabilities I am adding, I am going in a reverse manner. So the less probabilities should be less than 0.1. Then automatically this is more than 0.9. So let us see. What is the probability of x is 0? NC0 into 1 by 2 to the power of n. NC1 by 2 to the power of n. NC2 by 2 factorial into 2 to the power of n. NC2 itself, NC2 is this one, n into n minus 1 by 2. NC2 into by 2 to the power of n. Instead of putting like this, NC2, NC0 by 2 to the power of n. So this sum should be less than 1. So here how to calculate this? This is 2 to the power of n. This is 5n into n minus 1. This is 10n. This only way is trial and error method. There is no other way. So I am putting first n 10. I am getting left hand side 560, right hand side more than 900. 560 is not less than 900. I am putting n5. It is left hand side is 160, right hand side is 32. I am putting n8. Again, right hand side is less. I am putting n9. Putting n9. So I am putting left hand side as 460. What is left hand side? 10 plus 10n plus 5n into n minus 1. 10 into 9, 90. 5 into 9, 45 into 8, 360, 460. Right side is 500. So if I hit 9 hits with a guarantee of more than 0.9, the bridge will be 3 hits will be on the bridge. So 9 trials are. You see how the practical application of this concept, the probability concept, is a direct use of probability concept. So probability concept. Let us go some other problems. If the difference between mean and variance of a binomial variate is 5 by 9, find when n is 5. What is mean? NP. What is variance? NPQ. NP minus which is more? Is NP more or NPQ more? You see, Q is always less than 1, P is always less than, because they are probability functions. As Q is always less than 1, if I multiply NP with Q, it will be less than NP. So NP minus NPQ is equal to 5 by 9. I know N is 5. N is 5. So I am putting it P minus PQ is 1 by 9. So Q is what? P into 1 minus P. So I get P 1 by 3 and Q 2 by 3. When you solve this, P 1 by 3, Q 2 by 3. P minus P plus P square. So P square is 1 by 9, P is 1. It cannot be minus plus or minus 1 by 3, but minus cannot be minus. Probability can only be plus. So this is the probability. So now what is asked? P x is equal to 2. 5c2 1 by P to the power of 2 into Q to the power of 5 minus 2. So P is 1 by 3 to the power of 2, 2 by 3 to the power of 3. So this is a 1 by 3, 2 by 3. There are 3 questions are given. We have to choose one answer, correct answer. So correct answer probability is 1 by 3. Wrong answer probability is 2 by 3. It is like that. But of 3 choices, we are choosing. This is 5c2 ways. I can select 2. So answer is 80 by 243. Let us see. 9 ships is likely to be wrecked when they set in sail. When n is 6, find the probability. Out of 9 ships, 1 is getting wrecked. 6 ships, probability is less, but still there is a higher. At least 1 will arrive safely. Find the probability for at least 1 will arrive safely, and exactly 3 will arrive safely. These are the 2 conditions. So 1 in 9, so probability of wrecking is 1 by 9, and probability of non-wrecking is 8 by 9. It is success, it is fail. What is given is fail, 1 by 9. Please go on. So wrecking is the failure, so 1 by 9 probability, and successful is 8 by 9. P. At least 1 will arrive safely. At least 1 will arrive safely. So out of the total probability, I am giving 0 available safely. If I minus this, at least 1 will arrive safely. 1, 2, 3, up to 6 can be arrive safely. What is the probability? So 1 minus, what is x is 0? 6c0 into p to the power of 0 into q to the power of n minus. So 6c0, here p is, success is 8 by 9. Q is 1 by 9. 6. So this is the probability. 1 minus 1 by 9 to the power of 6. Probability. So for 3 to arrive safely, 6c3, 8 by 9 whole cube, 1 by 9 whole cube. Finally, bottom will come 9 to the power of 6. So into 8 cube, so this is 6c3. So 20 into 8 cubed by 9 to the power of 6 is the answer. We have to simplify this. 3, 6, 6 cancels, 5, 4 are 20. This is 8 cubed by 9 to the power of 6. We have to write in the smallest terms. Okay. So what is here important is 1 by 9 is not P. 1 by 9 is fail. 8 by 9 is P. So we have to use success and fail. We have to understand what is the question. We have to use this first or this first. We have to differentiate. That is, if mean and variance of this 2.4 and 1.44, find p less than 1 is less than x less than equal to 4. That means p 2, 3, 4 is asking probability of 2, 3, 4. So let us say this is NP, this is NPQ. When I divide this, I get Q, NPQ by NP. I get Q is 0.6. When Q is 0.6, I know P is equal to 1 minus Q. That is 0.4. 0.4. And what is N? From this I can substitute. NP is 2.4. So N is equal to 6 times. Now what I want? 6C2 into 0.4 square into 0.6 to the power of 4. This is P, 0.4. This is Q, 0.6. And 62, 0.4 square, 0.6 to the power of 4, plus 63, 4 cube, cube, plus 64, P to the power of 4, Q square. So this is the probability 1, probability is probability 2, probability 3. Why you have taken probability 4? This is equal also given. So we have taken probability 4 also here. So when I add this, simplify, I am getting 2268 by 3125 is the answer. It is given that 10 bulbs are manufactured by a company are defective. That means probability of defection is 0.1. In a sample of 20 bulbs, find the probability that more than 2 are defective, P2. So 20C2 into 0.1 to the power of 2 into 0.9 to the power of 20 minus 2. Let us continue. So 20C2, what is given is that more than 2 are defective. Given is more than 2 are defective. So I'm first finding out 2 are defective. Px is more than 2, sigma 20C 3.9 to the power of 20 minus r, 0.1 anything to the power of 10 to the power of 20. 1 by 10 to the power of r, 9.9 to the power of r, or taken 10 to the power of 20. Here, this can be done in 2 ways. Find the probability that more than 2 are defective. So I am putting probability of more than 2 from 3 to 20. 3 to 20. 20 C 3.9 by 10. 0.9 means 9 by 10. 9 to the power of 20 minus r into 1 by 10. 9 by 10 is equal to 10 to the power of 20. So this I have to add from 3 to 20. Or what way I can do? 1 minus P x is 0, x is 1, x is 2. These 3 I have to do minus. These 3 I have to do minus. Then I will get P more than 2 are defective. So if I put x is 0, NC 0, P to the power of r, P to the power of n minus r. NC 1, P to the power of r. N, here n is what? N is 20. And P 20C2, P is 0.1, Q is 0.9. So I have to add these 3 and minus. So both are same. We'll get same answer. So if it is 2, more than 2 are defective, then 1 minus this P. We have to do, I have not calculated yet, we have to do that. Let us see. Find the probability of guessing at least 6 out of 10 in exams, true false type, and 4 alternative types. This is general category. If there is a negative marking, whether we have to attempt or not. If there is no negative marking, okay, we are attending all the questions. We are putting whether we know or do not know, we'll put the answer. Because one may get right out of the 5, 6 answers. Suppose if they're negative marking, then whether I should do it or not. So this is the probability problem on that. Suppose there are 2 out of 4, we know 2 are not the answers. Only 2 are the answers. Out of 2, we have to put answers. Or there's only 2 answers are there. 2 are false. I have to answer. So at least 6 should be more than 6 out of 10 should be right. What is the probability? So this probability is half of. For true or false, probability is half of. So these 2 separate. 4 alternate we have taken separately. True or false we have taken. So 10C6, 1 by 2 to the power of 6, 1 by 2 to the power of 5. So 10C6 by 2 to the power of 10. For 7 to be right, 10C7 by 2 to the power of 10. 10C8 by 2 to the power of 10. 10C9 by 2 to the power of 10. All 10 by 2 to the power of 10. So if we add all these things, this is for 6 to be correct, 7 to be correct, 8 and 9, 10. So my total probability is 32%. So at least 6 will be correct. If true or false, my probability is 32%. Suppose if 4 answers are there, only 1 is correct. Then first is 1 by 4 P, Q is 3 by 4. So same, NCR, P to the power of R, P to the power of N minus R. So 3 to the power of 4 by 4 to the power of 10, 3 cubed by 4 to the power of 10, 3 square, 3 and 1. So this is 10C6, 10C7, 10C8, 10C9, 10C10. So here the probability is 15%. Here the probability is only for if you against 4 alternative, my chances of success above 6 marks is 15%. In 2 alternatives, my chance is 30%. Still less than 50. Still less than 50. Okay. If negative marking is there, that means what? 60% I'll get negative marking, 32% positive marking, positive plus 4, negative minus 2. Let us say the 0.3 into 4 is almost 0, 0. No, need not attempt at all. Okay. Let us see the another problem. Find the probability distribution for getting heads when 5 coins are tossed 320 times. 5 coins are tossed. Suppose each coin, when I toss, I get 1 by 2 is the probability. For 5 coins, 1 by 2 into 1 by 2 into 1 by 2, 1 by 2 to the power of 5, 1 by P to the power of R into Q to the power of N minus R. See, the probability of getting 2 in R times is equal to P to the power of R into Q to the power of N minus R into NCR. So what is P to the power of R here? 5 P is 1 by 2 coin 1 by 2. There are 5 coins. 1 by 2 to the power of R into 1 by 2 to the power of N minus R. So R get cancelled. 1 by 2 to the power of N, that is 1 by 2 to the power of 5, that is 1 by 32. This is this coefficient portion, the right side portion. Now, how way it can be chosen? 0 coins can be chosen. 1 head, 2 heads, 3, 4, 5, anything can come. So 5C0, 5C1, 5C2, 5C3, 5C4, 5C5 are the number of ways this can be chosen out of these 5 coins. So this is the distribution 1, 5, 10, 10, 5, 5, 1. So when I multiply this, what is the probability I am getting? Getting when in a 5 coin trial, suppose I have done 5 coins in one trial. This is all I am talking of one trial. One trial, 5 coins, I am getting 5C0 into 1 by 32, 5C1 into 1 by 32, 5C2 into 1 by 32. This is the distribution. If there are 320 trials, so into 320. So into 320 becomes 1 by 10. This is 5 by 10 into 320. 5 into 10, 50. Into this 10, 50, 100, 100, 50, 10. Because I am multiplying this by 320. So into 320, 332 tens. So first one becomes 10. Second 5 tens are 50. 10 tens are 100. 10 tens are 100. 5 tens are 50. 110 is 1. So this is the distribution for 300 coins of trial. So what way we have proceeded? For one trial of 5 coins, we have proceeded for one trial of 5 coins. If there are n such sets, n into that probability, which we are seeing earlier, n into that probability. So for one trial, we have done with 5C0 into P, 5C1 into P, 5C2 into P. This is a combination. This is a frequency distribution for the probability. Good. Let us understand. Let us continue probability distribution. Now we are going to cover Poisson distribution. Earlier we have seen Bernoulli distribution and general pattern of mean and variance. Now we are going to clear Poisson distribution. Let us see. Let us see if the number of trials is not available to us and it is not finite, then how to this Bernoulli distribution we cannot, binomial distribution we cannot do. Binomial distribution we cannot do. We have to do Poisson distribution, because in binomial distribution we have n. N is finite and less, but if this is not known, we have to use Poisson distribution. So let us see accidents on a highway. We know only number of accidents. We do not know how many missing cases are there, how many travel is there, how many vehicles have gone out there. We don't know. We have only record of say 5 accidents in a day or 15 accidents in a week. So we do not have any number of trials we cannot fix here. Similar snake bites in a field. Snake bites. We do not have, we have number of snake bites which are reported. But when miss, how many total n are there, we do not have this. But in binomial, we have both. When a coin is tossed, I have number of heads 1 by 2 possibility, number of tails 1 by 2. Here we cannot have such probability. So these times we will apply Poisson. If it is more than 40 times or 50 times, we normally will do. If 25 times head appeared, we know 15 times tail appeared. This is a very clear-cut case. But in Poisson, we do not have this number. So here the Poisson distribution has been defined as, in binomial distribution, we know NCR into P to the power of R into Q to the power of n minus R. But here it is e to the power of minus lambda into lambda to the power of x by x factorial. Where is this lambda is the parameter. Say 10 bites in a week. Say 5 accidents in a day. This is lambda. 5 accidents in a day. 5 absentees in a day in the school, classroom, like that. So this lambda is the parameter. So what is this now got? E to the power of minus lambda into lambda to the power of x by x factorial, as x is from 0 to infinity. Any number of trials is the random variable. So if x is 0, e to the power of minus lambda. If x is 1, e to the power of minus lambda into lambda. Lambda into e to the power of minus lambda. If x is 2, lambda square by 2 factorial into e to the power of minus lambda. Lambda cube by 3 factorial into e to the power of minus lambda. Like that, the probability varies. In binomial, it varies NC0, NC1, NC2, NC3, like that. But here, P and Q. P and Q. So, what are the characteristics of Poisson distribution? The outcomes of interest are rare relative to the possible outcomes. What does that mean? That means number of accidents, say 5 per day, there may be 1,000 vehicles traveling, crossing. So number of accidents are very less compared to the total number. Snake bites are very less compared to the possible snake bites. So the outcome is very less compared to the possible outcomes. This is an average outcome is lambda. Over a period of day, over a period of year, this is lambda is an average outcome. Occurrence of one outcome does not influence the change of other outcome. Like our red balls and blue balls. When blue ball is taken, I have to count less. Here it is not like that. Each accident, each occurrence is independent of previous or next occurrence. So they are independent activities. The probability that an outcome of interest is same for all segments. The probability is same because we are taking an average probability. Taking an average probability, the segment, given segment is same for all areas. Probability that an outcome of interest occurs in a given segment is same for all segments. So we have standardized this. Let us understand Poisson how we got this e to the power of minus lambda into lambda to the power of n by n factorial. This is what we have defined. E to the power of minus lambda into lambda to the power of x by x factorial is my Poisson distribution. How we got this is nothing but extension from binomial. Extension from Bernoulli. So let us see how we got this. Is a special case of binomial. Poisson is a special case of binomial. See, in a binomial NCR, p to the power of r into q to the power of n minus r. But you see here n is infinity. That's the difference between the binomial and Poisson. Here n is infinity. In binomial or Bernoulli, n is limited. So let us see with n is infinity. So I'm expanding this n factorial by k factorial, n minus k factorial into p is, suppose there are lambda accidents happen. Rate of accidents per day, but number is not known. Probability is not known. Then if there are lambda accidents happen, so if it is n is the number, if the probability is p, so n into p is lambda, say 10 accidents happen. Probability is 0.1. That means what? 100 vehicles have traveled. 100 into 0.1 is 10. So lambda, if it is observation, and this is the probability of my accident, so n into probability is equal to lambda. So when what is n becomes lambda by p, or what is the probability becomes p lambda by n. Lambda by n. So q is 1 minus p. So probability of accident is lambda by n. N we are assuming being infinity. So let us see this. So NCR p is lambda by n to the power of k into 1 minus lambda by n to the power of n minus k. So I am taking out here lambda to the power of k. I am taking out here. Yes. Now this I am expanding n factorial by n minus k factorial lambda by this I am doing to the power of n to the power of minus k. To the power of minus k. Now let us see from this figure how we got my e to the power of minus lambda by x of lambda. Here is my distribution. E to the power of minus lambda into lambda to the power of k by k factorial. This is converted to this. How we got, we'll understand. Let us say if n is infinity, what lambda by n becomes 0. So 1 to the power, lambda by n becomes 0. So 1 to the power of k. 1 by 1 to the power of k is 1. So this factor became 1. Now let this factor we'll see separately. Now here from which lambda to the power of k I am keeping as it is. This n to the power of k is brought here. Here k factorial is brought here. So my lambda to the power of k by k factorial has come from these two. Now n factorial by n minus k factorial into 1 by n to the power of k. Let us see this. What is this? This value should be 1. Let us see. Here I am writing nck is n into n minus 1 up to n minus k plus 1 by k factorial. If n is infinity, infinity minus 1 is what? Infinity. Infinity minus 2 is infinity. So all are n. So n into n, how many times? K times. So n to the power of k. N to the power of k by k factorial. If this two terms become n to the power of k by k factorial, n to the power of k, n to the power of k getting cancelled. So k factorial is remaining. So which you have brought it here. So n minus k factorial has gone in expanding. N to n into n minus 1 up to n minus k plus 1. So n minus k factorial further getting cancelled out. So by k factorial, this is the definition of NCR. So when n is infinity, this becomes n to the power of k, n to the power of k, n to the power of k getting cancelled, so it becomes 1. Now let us see what is left over. Only this portion. This portion is, I have to prove this as e to the power of minus lambda. Let us see. What we know, e to the power of expansion 1 plus x by 1 factorial, x squared by 2 factorial, x squared by 3 factorial, x to the power of 4 by 4 factorial, like that. This expansion is called e to the power of x. So we know the expansion of 1 minus x whole to the power of n, 1 minus n by 1 factorial into x plus n into n minus 1 by 2 factorial into x square, like that. So in place of x, I am having lambda by n. So 1 minus n by 1 factorial into lambda by n into n minus 1 by 2 factorial into lambda by n whole square, like that goes. If you see here, as n is infinity, n into n minus 1 is n square. So n square getting cancelled. N getting cancelled, like that. N to n, all these squares getting cancelled. Only lambda will be available here. So what is this becoming? 1 minus lambda by 1 factorial plus lambda by 2 factorial plus lambda by 3 factorial, lambda cubed by 3 factorial, like that. This is nothing but e to the power of minus x. It is e to the power of minus lambda. You understood? How we, if I put it to the power of minus x, what happens? Every alternate term is minus. This will be minus, this will be plus, because whole square is plus, whole cubed is minus, this is minus plus. So this is e to the power minus plus, it is coming. Because here it is 1 minus lambda by n whole to the power of n. N is infinity. So when I am doing infinity series, my n and factor bottom n square getting cancelled, n cube, bottom n cube get cancelled, and it is lambda square, lambda cube, lambda to the power of 1, like that. This series I am getting. This is nothing but e to the power of minus lambda. So what when n is infinity, the binomial probability is converting to e to the power of minus lambda into lambda to the power of k by k factorial. Okay. This is what we have defined earlier. This is what my Poisson probability distribution. Lambda is number of accidents per day, number of failures per work, like number of topographical errors in a page, anything. It is an average. So what is the n? Lambda by, this is np is equal to lambda. Now let us go. Now here also mean and variance comes into picture in a Poisson probability distribution. What is mean? Mean is x into p, k into p. It is equal to lambda. Here also it is equal to lambda. Even variance also is equal to lambda. So lambda is my parameter in a Poisson distribution. It is same as the mean. It is same as my variance. But in the binomial, mean is np, probability is p, mean is np. Here is lambda is also np. Basically lambda is what? N into p, which we have seen here. Lambda is nothing but n into p. So n into p, and here also, but variance is also n into p. Let us see how this has come. So x into px. So px we know. Let us see the derivation. X into px. So px we know in a Poisson e to the power of minus lambda into lambda to the power of k by k factor. So I have taken out e to the power of minus lambda being fixed. Lambda is fixed parameter, so I have taken out this. Only k is varying. So these three are k. So if I take k out, k, it will become k minus 1 factorial. So lambda to the power of, I'll write lambda into lambda to the power of k minus 1. So I'm taking out lambda also out. E minus lambda into lambda to the power of k minus 1 by k minus 1 factorial. K this. So when I convert it into j, k as j, this becomes again e to the power of lambda series. So this is nothing but e to the power of lambda. This series. See, if I put j is 0, 0 factorial 1, this is 1. 1 plus lambda by 1 factorial, lambda square by 2 factorial, lambda cube by 3 factorial is e to the power of lambda. So e to the power of lambda and e to the power of minus lambda gets cancelled out. The left out is lambda. Same thing is detailed explained here. So I have taken out e to the power of minus lambda 1 by x factorial, lambda to the power of x. So this is in place of x is 0 plus. In place of x, I am putting as y is equal to x minus 1. So y 0 to infinity, it becomes y plus 1 into this. So I am putting y plus 1 into, say, lambda also I convert into lambda. So I have taken out lambda, e to the power of minus lambda into 1 by y factor lambda to the power of 5. So this is nothing but total probability. What is this? This is total probability of the Poisson series from 0 to infinity. Total probability is 1. Total probability is 1. So this total is 1. So left out is lambda. Here we have come with the total probability in the sigma. Here I have come with total probability as e to the power of lambda. That is the difference. E to the power of minus lambda is kept inside. Here e to the power of minus lambda is kept inside, and we have converted this as a total probability, sigma p. Sigma p is always 1, so lambda into 1. So how we got sigma p? I have taken x as y plus 1. X as y plus 1. So in that case, what is this become? Y plus 1 e to the power of minus lambda into 1 plus x factorial is y plus 1 factorial into lambda to the power of y plus 1. Here lambda to the power of y into lambda is taken out. Y plus 1 getting cancelled, y factorial. So e to the power of minus lambda into lambda to the power of y by y factorial is nothing but the probability function distribution. So from 0 to infinity, all probabilities together is 1. So it becomes lambda. Let us see variance. We know variance is p x square p into x square minus px average x bar whole square. You know this is the variance. Probability into x square minus x bar whole square. Let us see p x square. So x square into e to the power of minus lambda into lambda to the power of x by x factorial. This we got from Poisson distribution from binomial and limiting n is infinity. So we are using here x square into p. So this I am writing x square as x into x minus 1 plus x. This is x square minus x plus x. Same way we are using here. Here also say x into x minus 1. Instead of plus x here, separately this x is taken out. You can use here itself plus x also. So I have taken x into x minus 1. Okay, because x square here x factorial, I want x into x minus 1 to get cancelled out. So I convert it to x into x. So this becomes two separate sigmas. Sigma x into x minus 1 into this plus sigma x into this. Sigma x into this is nothing but my, we have just seen, this is lambda. This is nothing but lambda. Now let us see this one. This one is x getting cancelled. So this becomes x minus 2 factorial. X minus 2 factorial. Lambda to the power of x minus 2, I have taken lambda square outside. So e to the power of minus lambda also I have taken outside. E to the power of minus lambda into lambda square sigma lambda to the power of x minus 2 by x minus 2 factorial. So this is multiplied again e to the power of lambda. When I put x minus 2 as y, this becomes e to the power of lambda. These two get cancelled. So this is lambda square plus lambda is this term. So lambda square plus lambda minus this lambda square. This is we have just seen. This is lambda. Integral x into p to the power of px is lambda. So with lambda square getting cancelled. This becomes lambda. So understood how the variance is arrived? How the what we have finally did? We have reduced it to a separate format, a separate series, so that it becomes again e to the power of lambda. Let us see some solved problems on this Poisson distribution. Suppose in a city 10 accidents take place in 50 days. Find the probability that there will be 3 accidents or more per day. So lambda is 1 by 5. 3 are in a day. So I am putting 0, 1, 2 in a day. I am reducing from 1. So 1 minus 0 accidents, 1 accident, 2 accidents. So this will result in 3 and above. So what is 0? E to the power of minus lambda into lambda to the power of 0 by 0 factorial. E to the power of minus lambda into lambda. E to the power of minus lambda, lambda square by 2 factorial. Lambda square by 2 factorial. When I deduct it from 1, I'm getting 0.001186. This is the probability there will be accidents of more than 3 in a day. Because 10 in 50 days, 1 day only 1 by 5. For 3 accidents, I almost we need 15 days. 1 accident, 5 days. Okay. Let us see. Lambda is given. Find the probability that no one joins in the queue in a minute. And this is one question. And 2 or more joins in a row for a ticket in a cinema hall. It is found cinema hall people are joining. No one joins in a minute. But normally 6 are joining in a minute. So what is the probability no one in a minute? So again same thing. It's of lambda into lambda to the power of 0 by 0 factorial. This is so what is 1 person joining? E to the power of minus lambda, lambda to the power of 1 by 1 factorial. This one. So 2 or more means I have to add these two. And 1 minus this. So more than 2 are joining in the ticket is a likelihood of almost 1%. Because daily 6 are joining in a minute. So 2 or more is likely possible. Most likely possible. So let us see here. 450 pages, 400 are there. So what is lambda? 400 by 450. So 8 by 9 is the per page. Errors per page. Find the probability. Random 5 pages have no error. Random 5. I have to select how. I am selecting 5 pages or no. So 1 page. First I am calculating for 1 page no error. So e to the power of minus lambda into lambda to the power of 0 by 0 factorial. That is e to the power of minus 8 by 9. For 5 pages have no error. So this into this for 5 times. So this whole to the power of 5. The probability for 1 page into another page, each page is the probability. So I am multiplying into 5. Now, it is estimated that 0.6% of the callers of the customer service department of Dell will receive a busy signal. Callers will receive a, if I am calling, please stand by, like that it is coming. So what is the probability that today 1400 callers, out of 1400 callers, at least 5 received a busy signal? Normally 0.6%, not 6%. 0.6 by 100. So 1400 callers, 5 received a busy signal. What is the distribution? What is use Poisson distribution? So at least 5 received. So I have to reduce 0 to 4. So minus px0, px1, px2, px3, px4, 1 minus. So px is 0. E to the power of lambda. What is lambda? Lambda here is .6%. See, 0.6% is the callers. So n is 1400. So n into probability is by lambda. N into probability. So 1400 into 0.6 by 100. 100 can cancel. 14 to 0.6, that is 8.4. You have seen here. n into probability is my lambda. So I got lambda here. So this is my distribution, e to the power minus lambda, lambda to the power of x by x factorial. So first one is e to the power minus lambda, second is lambda into e to the power minus lambda, third one is lambda square by 2 factorial into e to the power minus lambda, lambda cubed by 3 factorial into the power minus lambda. So all the four I am adding and I am reducing from 1. So less than 4 I am adding. At least 5 received a busy signal. So these people received a signal. So my answer is equal to 1 minus 0.0789. It is approximately 0.1 1 2. So around 0.02 is the probability. We have to do more and more practice so that we can get a full control on the subject. We have to attack more and more. In each example, we have to attack more and more problems from the wherever test looks you get, we have to attend so that we'll get full confidence on the subject. Once we learn the subject, there's no need of revision. That type of first time effort is to be